Hi, welcome to stoichiometry. This is 4.2, mole to mass and mass to mole of a single compound. First, let's start talking about the different kinds of molecules and formula units and vocabulary. So diatomic molecules are what I call the genuine seven. They're hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine, the genuine seven. Then you have molecules. A molecule is a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take place in a reaction. A formula unit is the empirical formula for any ionic or covalent compound. So things like C2H3 is an empirical formula, but that's a molecule, whereas C6H12 is not an empirical, so it's not a formula unit. The molar mass is a term used to refer to the mass of a mole of any substance. So it could be a single atom or it could be a compound. A mole, abbreviated just MOL, is the amount of a substance, and it will contain 6.02 times 10 to the 23rd representative particles. And a representative particle is the smallest unit to which a substance could be broken down, and it is known as Avogadro's number. You can think of Avogadro's number, 6.02 times 10 to the 23rd particles, like a dozen. If I have a dozen atoms, right? If I have a dozen roses, that doesn't mean I have a dozen petals. When you think about Avogadro's number, you think about if you had one molecule of H2O, you have 6.02 times 10 to the 23rd representative particles of H2O. Molar mass we found by adding up all the average atomic masses for the given elements in a given compound. So remember that a mole is 6.02 times 10 to the 23rd representative particles, or there's that many particles in any one mole of any one substance. So counting of those moles, every mole, whether it be an atom, ion, molecule, formula unit, whatever it is, contains 6.02 times 10 to the 23rd atoms or ions or molecules or formula units or whatever you're looking at, the representative particles. So correct terminology and identification, H2O is known as a molecule. Ki, however, is a formula unit. K2I2 might be a molecule. O2 is a diatomic molecule, and Ag would just be an atom. So the process to conversion. First, look at the right-hand side. These are your standard unit transfers. Grams per mole comes from the formula mass. Moles per mole is going to come from the balance coefficients of an equation like we learned last time. It's the mole ratio. So whenever you start your conversion process, you start with what you're given. Always start with what you're given. And then you do the dimensional analysis and make your units transfer first, then fill in your corresponding numbers with those units. And always remember that moles are central. Everything will go through moles at some point in time. So if you are given the problem, 2.5 mole of O2, how many grams would that be? Well, find the molar mass, start with the dimensional analysis, make your units transfer, fill in the numbers to cancel those units, and multiply across the top, divide across the bottom. So first we found the molar mass. The molar mass of O2 is 15.99 times 2, which is 31.98 grams per mole. Then we can set up our dimensional analysis. We start with 2.5 mole of O2 times 31.98 grams of O2 per mole of O2, so that the moles will cancel and you left with 79.95 grams of O2. To go the other way, again, you're given it a problem of 33 grams of C2H3O2. How many moles would that be? Well, again, it's the same process. Find the molar mass, start your dimensional analysis, make your units transfer, fill in your numbers, multiply across the top, and divide across the bottom. So we found the molar mass of C2H3O2 to be 59.03 grams per mole. We multiply, we start with what we're given, 33 grams of C2H3O2 times 1 mole of C2H3O2 per 59.03 grams of C2H3O2, ending up multiplying 33 times 1 divided by 59.03 to get 0.559 mole of C2H3O2. Allyl sulfide, which is C6H10S, is a compound that has the odor of garlic. So how many moles would be in 225 grams? Again, we can find the formula mass or the molar mass of 114.2 grams per mole, and we set up our dimensional analysis to cancel grams and end with moles, and we end with 1.97 moles of C6H10S. Hope these examples help. Thanks for watching.